Okay, so in my previous lecture, so we have discussed about the project size estimation, right? So we discussed about KLOC, kilo lines of code. I mean, LOC is a measure of project size, and then we discussed about function point, and then we have seen the difference between function point and feature point. Why feature point has been developed. So then today we will discuss about the various project estimation techniques. Okay, so I mean through these techniques we'll be able to estimate various project parameters, and these parameters are paramount important when during project planning. Okay, so so there are these parameters. So like project size is one, effort required, how much effort you really require to for a particular project, right? How much duration required, okay, to develop that particular project, how much cost will it take, I mean will it require, right? So these things need to be estimated, and I mean you need to estimate these parameters at very beginning, right, of the project, right? So accurate estimation of these parameters are very important. Okay, so you know these accurate estimations not only going to help in quoting an appropriate project cost, but also this will be helpful in resource planning and scheduling. This is what that is what I said. So these parameters are very important during project planning also. I mean, how you going to plan your resources, as well as how you schedule different tasks of a particular project. Okay, so if you have a proper estimation of these parameters, then so first thing is you can quote an appropriate project cost, as well as it will be much more helpful during resource planning and scheduling. Okay. Now, so there are various categories of these estimation techniques. So one may be the empirical estimation technique. The other one may be maybe a heuristic technique, and the other one may be a analytical technique. So we will talk about these three techniques, but we start with this empirical estimation technique first, and then we will into the other ones, the heuristic and the analytical approaches that we have for estimation of these parameters. Okay, so first it is a empirical estimation technique. It is based on making an educated guess of the project parameters. That means here, so so before we guess the project parameters, so we need to have some sort of prior experience of developing similar sort of projects. Okay, so if we have a prior experience of developing similar sort of projects, then probably you will be able to give an appropriate educated guess. You can do a appropriate educated guess of the project parameters. That is why. So here, so it is all based upon the experience, right? So there are experts, so they will be based upon their experience handling similar sort of projects. So they will be going through the SRS document. After understanding the requirements, maybe they will be able to say this would be the, I mean, let's say project parameters like one is a cost. Okay, so they will be giving a cost, okay, which is a guess. Okay, basically it's not a accurate estimation, but still these techniques are very popular in industries. So this is the way that people even estimate the cost also. We'll talk about this in detail. Okay, so although empirical estimation is based on common sense and subjective decisions, right? So it is all based upon experts decisions. Okay, so it is personal, you can say, decisions. Okay, because whatever the expert says, so we'll be going to, we'll be taking that as a approximated cost. So there are two such formalizations. So there are two such techniques, empirical techniques. So one is expert judgment, the other one is Delphi technique. Okay, so we'll talk about each of them. How, right? So we first start with the expert judgment, right? So it is widely used size estimation techniques, right? So mostly it is being used to estimate the project size. Okay, so here an expert makes an educated guess about the problem size after analyzing the problem thoroughly. Okay, after going through the problem, so an expert who have experience in handling previous have an experience of handling similar sort of projects in the past. So and expert estimates the cost of different components, right? So let's say for the part of a project or the software, so let's say you have n number of subsystems or modules, right? So he will initially estimate cost for each of these components, right? And then the summed up and the summation of all of these cost will be the estimated cost for this project. Okay, so here it is all based upon the expert. Okay, so it is based upon the expert. Now then what are really the shortcomings when we go with this expert judgment? So one is so human error or maybe individual bias. Okay, so that means that particular expert is biased towards certain things. Okay, or because human beings, so we usually make mistakes. Okay, so maybe because of some human error, so maybe the outcome will vary. Okay, or the person is little biased towards certain activities. As a result, maybe the estimations whatever he has given may not be that much accurate, right? Expert may overlook some factors inadvertently. Okay, so he may miss out certain factors, right? So may not have gone through all of the factors. Okay, so as a result also, whatever the estimations he will be giving may not be accurate all the time, right? Expert may not have relevant experience and knowledge of all aspects of project. That is what we say. So maybe that expert is good at database design, but he may not be good at programming language. Okay, as a result, what will happen? So during the cost estimations, right? So he may be giving accurate cost for the database module, but he may not have given accurate cost for the module which will be developed using some programming language. So he has not considered that. So as a result, what will happen? So at the end, as a whole, we will see different size estimations. Okay, or I mean, we are not going to get the accurate one. Okay, accurate estimation, right? So this would be the shortcomings of this expert judgment. So now, can you tell me, anyone out here, can you tell me, I mean, can you further improve this? Is there any way that can you improve this expert judgment?
We can use more than one
So like
expert.
creating a group of experts.
Okay, okay, yeah. So right, fine. Okay, right. So that's fine. So you always I have all slides. Okay, maybe few students little smart in going further the slides, right? And few may not be going into, but so whenever I ask something, so you should use your brain, so to answer. It's honestly you should try that way. That then you can understand, whether you are you yourself have a estimation. You can estimate that whether you are in line with the concept or not. Okay, right. So anyway, I'm going through all these slides. You will be also going through, but say at the same time, you should be trying in your way. Okay, that is what will help us. You and me as well as others to be with the subject, uh, taking everything very effectively. So that is what. Okay, fine, right. So now, all right, there is a expert judgment, right? So refined form is the estimation made by a group of experts, right? So you can say, if you wanted to remove those bias, because there are, if you're taking only one expert, right? So he may be biased towards certain number of activities, right? So now here what you try to do in order to remove those bias, maybe you can go up with certain group of experts, right? So a lack of familiarity with particular expert. So still here also, even you pick a group of experts, still some aspects of the project may be missed out. Okay, so personal bias, so still there will be a personal bias. Maybe you improved a lot, but still there will be some personal bias, right? So maybe you do not know how many people that will be there in a group representing each and every aspect. So that is not known, right? So desire to win the contract through overly optimistic estimates, right? So sometimes it can happen, when you're going through these sort of mechanisms, right? Maybe the judgment mechanism, expert judgment mechanism, right? Or the technique. So where we always try to get the contract, right? Because you can think of something like this. Okay, so there is a project. Okay, now, so there are multiple companies, right? So let's say there is a TCS, Wipro, Infosys. So these are all Indian companies, right? They wanted to get that particular project. So then what they do? So they always try to they always try to you know win that particular project, because there are three competitors, so we have only one project, right? So everyone try to uh, get that particular project. So as a result, what they do is, so they are very optimistic about their success, right? So is to give the optimistic estimates. Okay, so if they give optimistic estimates, then probably they're going to win that particular contract, right? So individual oversight is minimized. Even a estimation is done by a group of uh, experts, but still the problem will be there. You may be inadvertently you're going to miss out certainly few aspects, but yes, so that will be minimized. Okay, because here many people are involved. Okay, a group of experts are involved. Let's say you oversighted one of the aspects, so the other one can pick out, okay, that particular issue, right? So this way it can minimize, but still there will be problem, because we are all human being, right? So human error still we continue, okay, with these estimates. Okay, so a group of experts still may exhibit bias. Okay, so due to political or social consideration, maybe depending upon some social considerations. Okay, so maybe due to these all different reasons, right? Maybe the entire team be biased towards. Yeah. So that is what I said, you right. So because you wanted to win that particular contract. Okay, so all of these team members, they may be biased, or they may be talking to each other, and then they will be coming up with a very optimistic one. Okay, so that means this is the way that still you will have that sort of bias. Okay, biasness. So decision may be dominated by overly assertive members. So sometimes it will happen like uh, you know in a good group of experts, still, there are some senior people in the group, senior members in that particular group who always, wanted to have things in their way. So according to them, so things should go on. So like they try to, bias the whole team, right? So they will be dominating, the senior people will be dominating, right? So that may also happen during expert judgment, right? Now, so there are these, disadvantages because of which. So now there is another estimation technique. So this is what we call as Delphi cost estimation, right? So team consisting of a group of experts and a coordinator. So here you will have a number of experts, okay? So similar to the previous case, but there will be a coordinator here, okay? And now this coordinator, so at very beginning, so the coordinator will distribute the SRS to each of the experts, okay? And along with that SRS, so he will also include a form, in which these experts, okay, they will give their own estimates, okay, they will provide their own estimates in a particular form, okay. So form and the SRS will be distributed by the coordinator to all the experts, right? So anonymously carry out the task and submit it to the coordinator. So the SRS and a form is given to each of them, okay. Now they will carry out their estimates and maybe giving in an envelope, okay, with some seal, okay, they will submit it to the coordinator. Now so whatever the estimators or the experts, so if they have they have found any unusual characteristics of the product which actually influenced the cost whatever given by the estimators, okay, so that can be mentioned out, okay, in their that form, okay. That means this is the maybe with some justification they will be saying that this particular characteristics of the product actually influenced more this particular estimate, okay. So they can mention on that, okay. Now, so what a coordinator will do after receiving all of these estimates. So now the coordinator will prepare a summary of these responses. Okay, that means whatever the responses came in the form of a form. Okay, so taking those responses, as well as whatever the unusual, rationale or the characteristics which actually influence the estimators have also been uh, part of the summary, okay. So this prepared summary information is again distributed to the experts or the estimators, okay. So that means after taking after taking all the estimations from the experts, okay, so the coordinator will prepare a summary, okay, and that summary will contain all the estimations of experts as well as any of the characteristics that actually influenced their estimations, right? So now this summary is again distributed to the estimators, and once again the estimators will re-estimate the cost, again they will be submitting, right? But here you can see now these estimators are not allowed to talk to each other, okay. So they will not be talking to each other, okay. They will be carrying out their own estimations. Only thing is that any parameter that influences characteristics that influences their estimation, those are mentioned, but that will come as a summary, right? And no one knows who has identified that particular characteristics, okay. I mean those things will not be known, right? Only thing is that a summary will going to each and everyone, right? Now, so usually this process is iterated for several rounds. That means it will be continued for a several rounds, right? And as I told you, so no discussion is allowed among the estimators. Okay. Otherwise, what will happen again? The overly assertive senior members or assertive or the senior members, so they will always you know dominate uh, the estimations, right? Because they will be right. So that is the reason why this is not allowed. Okay. So usually what will happen, let's say there is a very senior person, so if whatever he gives his estimations, then what will happen, the junior estimators, so they will also little follow the senior person, right? So because the senior is giving whatever the estimation that must be appropriate, they may feel at some point of time, and then as a result you may be going to get the poor estimations. Okay, so this is not allowed. Okay, that is what part of a defi cost estimations, right? After several iterations, coordinator compiles the results and preparing the final estimate. Okay, so maybe this iteration will be carried out for several rounds, right? After several rounds, the coordinator will come up with a final result or the final estimate. Okay, though it consumes more time and effort, removes unjustly be influenced by overly assertive senior members. So that means, so the influence will be removed, that will not be there, but it will take definitely more time. Okay, this will take little more time because before every iteration starts, so the coordinator has to prepare a summary of the previous round, and then it has to be distributed, and then again they will be carrying out, we will be giving some time, and then they will be so this process exactly takes more time. So any doubts of our students? Anyone? Is there any doubt? Someone should say also, yes sir, we do not have doubts or something like that. If you say, I feel at least confidence that actually
Sir,
you
no
are.
doubt.
Yeah, so you say, if you have at least one or two say something, so then I will have some confidence that you are listening to my talk, and it's otherwise it looks very boring, right? So I cannot see you all here like the lecture hall, right? So I keep looking at my slides, right? I do not know whether you understand everything, or sometimes I cannot put all cross questions also. It is not that much difficult. Yeah, so whether you are attentive or not, so everything, so this is completely a virtual world. Okay, so uh, so you should be sometime, either you should be asking some question, or maybe if you do not understand, also say something. Or sometimes when I ask some question, you say yes or no sort of things, at least I will uh, get a understanding that you are in line with my topic, huh? Right? So yeah, so then I understand, so you understood everything till now, right? Now we will be getting into a heuristic technique, right? So you understand by the meaning itself. So heuristic are something, one, the techniques which always try to discover something. Okay, right? So I mean, so this is the way that we carry out, right? So it's maybe based upon some experiments, right? So we carry certain number of experiments in order to come up with something, right? So now these heuristic techniques, so they actually assume, they assume that whatever that project parameters that you have, so they no they have some sort of relationship among themselves. Okay, so these parameters will have have some relationship uh, among themselves, right? So this is what, right? Now if they have some relationships, okay, then we can usually in a model using some mathematical expressions, right? So you can think of some sort of regressions and all, right? So you can find, okay, so how one parameter can affect the other parameter. Okay, so this sort of thing, right? Now these heuristic estimation models, so they can be broadly classified into two. One is single variable model and the other one is multivariable, right? So you understand. So your mathematical equation will have single variable, or your mathematical equation will have multiple variable. That is the multivariable models. Okay. So now, so here the variables are the ones, they are the independent estimates. Independent estimates of the, I mean, they are the independent parameter estimates. Okay. So you can say, so some parameters which are independently estimated, right? So after, you have estimated independently, now you try to, find the relationship with the other parameter, or you can see like the other parameter can be predicted based upon this independent variable, right? So this is what exactly we are trying to do, right? Let's say you can think of like this. So you have project size in terms of KLOC. Okay, so from project size, that is independently, I mean, you might have estimated using some technique like function point or KLOC, so whatever may be. Okay, so you have a project size estimate. Now from the project size you can easily estimate, let's say, effort. Okay, you can predict how much effort will be required if the estimates, if the project size estimate is this. Okay, no, so now here the independent variable is KLOC, and now dependent variable here is which one? It may be the effort. Okay, so because the effort is predicted based upon the independent variable KLOC, right? So this is the way that you can need to understand. So single variable model assume that various project characteristics can be predicted based on a single previously estimated basic independent characteristic of a software such as project size. Okay, so now you can think of here. So here is the estimated parameter. Let's say the estimated parameter can be given in this particular expression. Now here you can see C1 multiplied e to the power of D1. That means so exponential power of D1, right? So here D1 is a exponential power of so exponentially, so it is varying. Now you can see, so E represents what? It is a independent variable. Let's say you have a KLOC, right? E is the KLOC. Now we know the project size is in KLOC. So then you can always estimate the other parameter. Other parameter here will be maybe effort or maybe duration or something like that. Okay, so that means we try to predict, okay, some parameter based on a already estimated independent variable. Okay, so C1 and D1 are the, here what? They are the constants. They are the constants, and these constants are actually obtained by studying various numbers of similar sort of projects. Okay, after studying various similar sort of projects, so people have developed that the constants will be C1 and C2, C1 and D1 will be these values. Okay, so these are the constants, but you have a independent variable, right? So then you can estimate or you can predict the other parameter. This looks like this form of, because here you have only one single variable. E means only a single variable here used. Okay, so this is a single module, right? A model. Now, so we can see there are multivariable model where you will have multiple independent variables, okay, independent parameters, and those are already estimated. Then you can estimate certain things, right? So now you can see the equation here. Estimated parameter is equal to C1 multiplied E1 to the power of D1. Here U1 is one independent variable. Similarly, E2 is another independent variable, right? And now C1, D1, C2, D2, they are the constants. Okay, so they are the constants. Okay, these constants exactly determined from the analysis of the historical data that has been collected from the past similar projects. Okay. So these values are the constants, right? Now you can understand. So these multivariable estimation model are more accurate than single variable, because you can understand now, because we have considered various characteristics, right? So because of various characteristics, okay, so definitely you will be able to get the predicted one is very much accurate. Now, so usually, so we'll talk about a COCOMO model. So it is a heuristic estimation technique. Okay, so COCOMO is actually constructive cost estimation model. It is it was proposed by Barry Boehm. Okay, so the one who proposed, can anyone tell me? So Barry Boehm proposed what process model?
Spiral.
Yes, good, good, Satendra. Yeah. So he is the person again. So has developed the heuristic estimation techniques, right? So it prescribes a three-stage process, for project estimation. So here we'll be going through three different steps. Okay. So in the very first stage, or the step, so actually we carry out some initial estimations, right? And over the next two stages, you will going to see some refinement to the previous steps, so as to come up with the accurate estimations, right? So it uses both single and multivariable estimation models at different stages of the estimation. So we'll see that. Okay, so I already discussed about single and multivariable estimation models. So the examples I have given you, right? So the predicted variable, the predicted parameter is based on single variable, or it is based on multiple variable. That is what we have seen, right? So now, so this COCOMO, so as I told you, so it has three different stages, right? So the first stage is called as basic COCOMO, and the second stage is called as intermediate COCOMO, and the third or the final stage is called as complete COCOMO. Okay, so we'll talk about each of them. Okay. Now, so part of your basic COCOMO model, so Boehm, so he postulated, okay, that any software development project can be classified into organic, semi-detached, or embedded. Okay, so according to their complexity, okay, so according to their complexity, project complexity, so actually, we'll discuss about what is organic, what is semi-detached, and what is embedded in the next slides. Okay, but now as of now you can understand. So Boehm, categorized all the software projects, into these three. Okay, you can think of, right? So it can be organic or semi-detached or embedded. So now, and then he developed or he estimated, effort and duration from the, project size estimations. Okay, whatever the project size estimations are there, I mean, that has been, independently already been carried out, so then, using basic COCOMO model, you will be able to estimate effort and duration. I mean, how much effort you really require, and how much duration you really require to finish that particular project. Okay, if the size estimate is already done. Okay, so now he has given three different sets of formulas for these three types of projects. Okay, so if the category is organic, so equations for, I mean, expressions are there, right? If it is semi-detached, so expressions are developed, and if it is embedded, so expressions are developed, right? We'll see those things now. So apart from that, okay, so Boehm postulation, okay, so what Boehm postulated, right? Apart from that, so basically these software projects are classified. I know they have these basic classes. Okay, there are certainly three basic classes. Okay, those are so usually classes are corresponding to kind of application that we are developing. Let's say so one class is something data processing programs example, right? So you have a development of applications, right? Or it's a utility software, or it can be a system software. Okay, so these are the basic software classifications, right? So so best example for this application is data processing programs. Okay, where it takes some input data and then it processes and it is going to give you output, right? Whatever the programs today you are writing, almost all. Okay, and there are some softwares like utility softwares. So utility softwares are the ones like linkers and compilers, right? So they are being utilized, so if you have written a program, right, so these utility programs are exactly used um, in order to help the system perform in a better way, you can think of, right? So now there are system software. So very best example here is operating system. Hmm. So you know that these operating system, usually the system programs, right? So part of operating system, now they directly interact with the hardware. Okay, so as a result, what will happen? So you see some sort of programming complexities because writing programs for hardware devices, so they are very critical, right? So they have some sort of timing requirements, constraints. We'll be seeing that how how different processes can be concurrently run. So these are all various aspects associated with any system programs, right? So that means as a result, so system programs are the one which will take more effort. Okay, or they really they are much more complex, right? So now this is what the way that basically all software project developments are classified. But according to Boehm, what it says is, so not only you need to consider the characteristics of the product, but also you need to take development team and development environment. Okay, so I mean, what development team you have, okay, I mean how skilled people that you have, and in what environment, okay, so this development will be carried out. So these all sort of things should be taken when you are going to estimate certain parameters. This is what Boehm says. Okay, then he classified the projects into organic, semi-detached, and embedded. Okay, do you understand now? So this is the way that, okay, so here according to Boehm we considered the development team and environment also. There are certainly many other factors while we estimate these parameters. Okay, so according to Brooks, okay, so what he says, so product development complexity, no, no, I mean, they are how difficult to write, the product, or the program. That for these all three categories like application, utility, and system software, whatever the basic classes we said, that follows a ratio of 1:3:9. Okay, so let's say it's an application program. So whatever the effort you really require, okay, I mean how complex it is to write that particular program. So they follow this ratio 1:3:9. Okay, that means the operating system programs, whatever you are going to develop, okay, that takes three times more than the utility software. Okay, and it is 9 times more than the application program that you can think of. Okay, this way. Okay, the ratio follows. Okay, so that means that the complexity will vary in this ratio 1:3:9. Okay, so if it is an application program, that means the complexity will be very low. Okay, if it is a system software or you developing a program for operating system, so usually the complexity will be much higher than the simple application program. Do you understand so far? Any doubts so far, student?
No, sir.
No, sir.
Okay. Now I say, so there are now according to Boehm, these are the different three what you see, these are the three uh, categories, right? So the first category is a organic. So whenever the project is a very well understood application program, I mean all the requirements are known. Okay, so and it is very the development team who is going to develop that particular project, if it is reasonably very small, okay, and the team members are very experienced and they have developed similar sort of project in the past, then that sort of project is considered as organic. Okay, the other semi-detached is where so you will have a some experienced and you have some inexperienced people as part of development team. Okay, and here the team members will have limited experience. They will as compared to the organic, so they will have very limited experience. Okay, so maybe they have limited experience on some systems, some related systems. Okay, but and also they may be totally unfamiliar with some of the aspects of the system. That means so they have limited experience on some related systems. Okay, and they will have no experience at all. That means they have not familiar about some of these aspects of the particular system which is going to be developed. Okay, so if this situation are there, so then that sort of software project development is categorized as semi-detached. Okay, you understand? Now when can you say that it is a embedded type? If the project is strongly coupled to hardware. Okay, so that means the software that you whatever you are going to develop, that's completely going to interact with the hardware system. Okay, so you can think of, right, if stringent regulations on the operational procedure exist. Okay, so I mean it should follow certain number of regulations. Okay, so while you developing such sort of software, right? So then and also here the team members may have very limited experience. Okay, and also some of them may be totally unfamiliar with some of the aspects of the system. Okay, so that means so that sort of project is categorized as embedded. Okay, so embedded are the ones where you have very strict regulations and the project is strongly coupled to the hardware. I mean now you can think of embedded means, let's say for example you going to you're going to develop some sort of maybe a software for what you say mm, refrigerator or software for um, oven or software for something. So like so there are certainly some guidelines always, right? Let's say oven, microwave oven, right? So microwave ovens, right? So they works with certain frequency ranges, right? So now so those frequency, you need to follow certain government guidelines. Okay, you are not allowed to, without any permission, you are not allowed to develop a microwave oven because it uses some sort of frequencies, right? By using those frequencies, you generate heat by bombasting various electron, proton, and all those things, right? So there are physics concept, right? I'm not going to discuss about those, right? You can now you can think of, right? So now, so you need to think of, right, the software or the project which is strongly coupled to any sort of hardware and also some stringent regulation, they are categorized as a embedded. Okay, so this is the way that Boeing categorized these projects, right? So for three products category, Boeing provides different sets of expression to predict effort. Okay, so he has given some expressions, okay, through which you will be able to predict the effort. That means in units of person and months. We'll talk about that. What is it? What is that person and months? Okay, so as well as he is going to give the expressions for development time. I mean, how much time required uh, for that particular project if the project size is given in KLOC, okay, kilo lines of code or kilo lines of source code. Okay, so 1% month is the effort an individual can typically put in a month. Okay, so usually whenever we say, so you can think of like this. So there can be a person. Okay, when you say 1% month, so usually we understand that, you know, there is a one person, okay, who can typically you know, work for a month. Okay, that is what we understand 1% month. If you say 1% month, so that is what we understand. So implicitly takes into account the productivity losses that normally occur due to time lost in holidays, weekly offs, coffee breaks, etc. all. So now Boehm, whatever he has developed, you know, derived the expressions by taking the data from various similar sort of projects, right? And while you developing this project, so he has considered these all losses, also productivity losses, right? So I mean, let's say I said one person is working a month. This means this doesn't mean that, okay, so the person is working 24/7, you know, for a particular month. So usually he is going to a office, he will be working for 8 hours, you know, out of 8 hours, so he will be, you know, maybe he will be going to a coffee break, he will be taking some coffee break, and there are, you know, some holidays also, there are some weekly offs also. We have taken into that consideration also, okay, while you calculating this estimations, right? So that is what he says. So person month is considered to be an appropriate unit for measuring effort. So this is the unit for effort. Okay, so we will talk about that person month, what is. So from this you may be a little bit about to understand, right? So 1% month means something like this. There is a person who will be working for a month. Okay, so this is what as of now you understand, right? So fine, in the next slide you will be better understand, you will better understand about this person month. Okay, because developers are typically assigned to a project for a certain number of months. Okay, because, you know, so these developers will be, you know, so you know, assigned, you know, maybe they will be going to take 2 months, 3 months, 4 months. Let's say there are programmers, right? So programmers will take some certain months to finish that particular task. Okay, so right, so that is the reason why it is person month. Okay, so base effort estimation of 100% month doesn't imply that 100% should work for 1 month. Okay, so if somebody says 100% months, okay, so if the effort is given as 100% month, so it doesn't mean that, you know, 100 people working for a 1 month. Neither does it imply that one should be employed for 100 months. So you can, and you cannot think like this also, right? So one person will be working for 100 months. 100 persons, there are two ways. Okay, you can think of 100 persons working for 1 month, or one person working for 100 months. Okay, so this is not the interpretation actually. Okay, when you say 100% months. Okay, so what we say here is, so effort estimation simply denotes the area under the person month curve for the project. Okay, so it is a area under the curve. Okay, so that means, so your x-axis will have number of persons and your y-axis will have months. Okay, defined in months. Now you will have a curve, right? So when you vary the number of persons, right? So let's say at time t0 you have a 2 persons deployed. Time t1 you have 4 persons deployed. Time 5 you have 6 persons, right? So on. At different times you have different, those people are deployed for different months, right? Now you can draw a curve, right? So when you draw a curve, so area under that particular curve is going to give you the effort estimation. Okay, so that is what you need to understand. So it is a area under person month curve. So in the x-axis you have a person and y-axis month. Okay, area under that particular curve is going to give you effort estimation, right? So it's not that one 100 people working for 1 month or one people is working for 100 months. It is not that much. Okay, so it can be something like this. So let's say you have a 1 year of time. So every day maybe you are employing some people, right? Some people you can think of. So the first day one people is employed and he will be carrying out his activity for 3 months, and after which he will not be doing any other activity, right? So maybe his job is done, right? So maybe the other person will come in. Okay, so he will carry out certain other activities. Okay, so like you have at every time instant you have different number of people, and you have different durations for them to work, right? So that is a way that you need to understand, right? So then the area under curve will be going to give you the effort estimation. The number of personnel working on the project usually increases decreases by an integral number, okay, resulting in a sharp edges in the plot. Now you can understand. So usually sometimes it will increase, sometimes decrease. So now so area under curve, how you going to get this area under curve? Anyone, any student? If there is a curve given, okay, so how you going to find the area of that particular curve?
Using integrals, sir?
Yes, so you probably studied. So there are various techniques through which you can find out area under curve, right? So like integration and all, right? Excuse me. Right. So now, so part of your basic COCOMO model, so Boehm given these expressions, right? So they are all single variable heuristic model, okay? Because it only takes only one independent variable and then it is giving to predict, okay? Now you can see the effort can be calculated from KLOC. That means project size is estimated independently. Now we have the project size in KLOC, then you can estimate, you can easily estimate the effort, okay? Now effort, once the effort is estimated, that effort is given in person months, okay? So A1, A2 are the constants here, right? And now once the effort is computed, then you can compute the development time. Okay, so development time is dependent on effort, right? So here the development time is a dependent variable and your effort is a independent variable, right? So B1 and B2 are the constants, so you will be able to get the months. Okay, now KLOC is the estimated size of the software product in KLOC. Okay, so A1, A2, these are the various constants. As I told you, these constants are determined based upon the past historical data of similar projects, right? Now, so the effort, so whatever the total effort can be required to develop a particular software, is expressed using person months. Okay, so according to Boehm, every line of source code should be calculated as one LOC irrespective of the actual number of instructions on that line. So I told you before also. So Boehm here, what they considered is, so they counted the number of lines of source code. Okay, so sometimes, as I told you before also, there are some programmers, so they try to write uh, I mean, you see, actual number of instructions, maybe they are going to write on the single line, or they may be writing the same instruction and spanning different lines of code, right? So different lines, right? So now this is all. So what Boehm assumed here is he counted only number of lines of code. Okay, so he has not taken that into account. Now, as I told you, so there are these three different category of projects, right, for which the effort can be calculated like this. So here the constants, let's say if it is an organic project, 2.4 is the A1, and exponential power you see there is 1.05 and KLOC, right? So this is the expression given to calculate effort, okay, given the KLOC, okay. So similarly for semi-detached, the effort can be like this. So embedded, the effort can be 3.6 into KLOC to the power of 1.2. So now once these efforts are calculated, now you can calculate the development time. Now here the development time is calculated. Here the constants are like this, 2.5 and 0.38, okay, for organic project, and semi-detached. So almost this 2.5 and 4 to the power of 0.35. So like this, okay. Now the development time you can see here is now if you see this thing, so for all here is part of this expressions. Now can you tell me which one is increasing superlinearly? I mean whether the effort is increasing superlinearly, or the development time is increasing superlinearly. Which one? Which one will have more slope? If you draw this graph, okay, so if you see in the y-axis, if you plot effort, and in the x-axis if you plot size, okay, KLOC, so what will happen? So how the curve will, what type of curve we will be going to see? Can anyone?
Development
Huh?
in development costs increases exponentially.
Exponential.
So there are both are exponential, okay. You see this is a exponential curve, but which one is super linear? That means it will be
Effort.
effort, right?
Effort.
Because the slope is 1.05, you can see there, okay. 1.12, that is more than 1, okay. Now part of your development time, the slope is 0.38, okay. So now you can see here, okay, so you can come up with certain number of you can from this the expression. Now you can see so the effort is increasing superlinearly, whereas your development time and effort, if you see, it is not that much superlinearly, but but still it is a linearly increase, okay. Now you can see another observation from this. Now you can see here, so the effort required for embedded system, is more than semi-detached and organic. Yes or no?
Yes, yes, surely.
Yes. Why it is more?
So because the power is 1 point, hello,
Yes, power is 1.2, as well as the
and the
constant is also
substance 3.6.
the 3.6. Okay, A1, maybe A1, A2, A3. If you see like this, A3 is also more, right? 3.6. So that means here embedded system takes more effort. But now come to this. Okay, so if you see about the development time, which one will take more?
Organic, sir, organic.
Organic takes more development time, okay. But if something, now you tell me embedded takes more effort, but your development time still takes little less, as compared to other projects. Why it is taking little less? You see, something takes more effort, requires more effort, so that should also take more time also, right? I mean, effort is what? How many number of people working for that particular project over a certain duration, right? That is what. If I say more people will be deployed and more people are working for a longer time, okay, we are saying in terms of effort, but the development time is suddenly decreasing. Why it is happening? Is there any reason? Okay, so there is
Sir,
a
work is
reason.
being
Okay.
divided. Sir, the work is being divided into
Yes,
employees.
yes, yes. There is a scope for parallel activities. That is what we say. Okay, so there is some scope for parallel activities. Okay, so that means because it's a large project. Okay, so maybe there are large number of people working. So we can definitely find some, we find some parallel activities and then we carry out those activities parallelly. As a result, so somehow we try to reduce the development time. This is what it all says. Okay, clear? And now the rest of the interpretations you do understand, right? Your duration curve, that means the development time, they increase superlinearly, does not increase superlinearly as compared to the previous one, because the slope is here less than 1. Okay, so that means it is not going to increase superlinearly, right? Okay, so now so this is what so the first case here is, so in case of effort it is a superlinear because the slope of the curve is greater than 1. Okay, so now this is because of which, okay, so effort required also increases rapidly with the project size. If the project size increases, so usually your effort will be required more. Okay, but your development time is not superlinear, but it is a sublinear. Okay, because the slope is less than 1. You can understand, right? So yes, I think our time is up, right? So now so here so basic component part of which, so it is exactly helping us to estimate the cost. Okay, now how you can calculate the cost? So the person month, that means you have got the estimated effort. Okay, so once if you got the estimated effort, that means efforts are known, right? So these many persons working for this many number of months. Okay, if that sort of information is with us, then what you can get, so you can simply calculate the cost by multiplying the effort by the manpower cost per month. Okay, if you got 20 person months as a effort, now then you can multiply. Let's say one person is paid 100 rupees per month or 1 lakh rupees per month, then you multiply that. Okay, so that is what going to tell you the overall cost of the project. Okay, so now assumption that entire project cost is incurred on the account of the manpower cost alone. Okay, so it is all based upon the manpower cost they have considered. Okay, in addition to manpower cost, a project would incur overhead cost due to the hardware, software required for the project, company overheads, like whenever you are going to develop any software, right? Usually you require office space, you require electricity, right? You have many other overheads, right? So those things need also be used. Okay, but as of now we have seen, so project would so those things. So here what it assumed here is, it is only takes into account the manpower cost. Okay, so the person who are paid uh, as a salary. Okay, clear? Yeah, can I stop now?
Yes, sir.
I think you have another lecture at 1:15.
Yes, sir. Yes, sir.
Yes, sir.
Yes, yes.
Or can you give me 5 more minutes, because I can finish up, only there are 5 slides left. Can I continue for 5 more minutes?
Yes, sir.
Only five slides are there, so that this topic will be over.
Yes, sir.
Okay. So give me 5 minutes, we will finish up. Okay. So, so that is what part of basic COCOMO model, right? Now you have an intermediate COCOMO model. So I told you there are 3 phases, right? So as part of intermediate COCOMO model, so part of basic COCOMO model, what it assumes, the effort and developments are the function of product size. That is what we have seen. Okay, so effort is developed. Effort is developed using KLOC, right, as a product size. And other parameters affect the effort and development time. Okay, so now what I'm trying to say, so not only this parameter, there can be many other parameters which can affect your effort and development time. Okay, so effort to develop a product would vary depending on the development environment also. Right? So as I told you, so what is the development environment we are, where we are developing that particular software. Okay, so we have not considered. Now we need to consider, right? Development environment is also very much really required, right? So let's say you can just understand by like this. Okay, so if I going to give you a if I ask you to develop a software, small software, okay, and I will give you a notepad. Okay, I will give you a notepad. So by notepad or by notepad, so through notepad you need to write your program. Okay, and I give the same project to other student. Okay, I give the same project to other student, and along with which I will give you some sort of IDE. You understand what is IDE? Anyone? IDE.
Integrated development environment.
Right, integrated development environment. So they are like NetBeans and all, right? Or you have some sort of let's say if it is a Eclipse, maybe Eclipse, NetBeans. So there are various IDs are available through which you're not really required to remember all of your API. So that will actually help you to write the program very quickly, right? So now that is what the development environment is an example. You see, okay. So if you using a better tools, usually you will require little less time to complete that particular project. Okay, so now you need to understand this way, right? That is what I'm trying to say. So this is what not considered as part of basic COCOMO. Okay, so all relevant parameter must be taken into account. It recognizes this fact that defines the initial estimates. Okay, so if you take into this development environment into consideration while you calculating the effort, so usually you are actually going to refine your estimates. Okay, you are going to come up with a better estimates, right? So note, so the intermediate COCOMO model refines the initial estimate obtained using basic COCOMO expression by scaling the estimate up or down based on the evaluation of set of attributes of software development, right? So now whatever the other attributes, and I mean, as I said, you one attribute maybe you use some sort of tools, right? IDE. Okay, so if you have taken certainly some software development environment, and certainly you have certain number of attributes, right? So by evaluating those attributes, now after that what you can do is you can multiply or something like that. You scale whatever the estimations that you have obtained in the basic COCOMO, and that will be scaled. That will be scaled based upon the various attributes. I mean, based upon the various other parameters that you have taken into consideration for estimating your project. Okay. Now intermediate COCOMO, so it all uses set of 15 cost drivers. Okay, so that means these are the multiplier. That cost driver means, as I told you, one of them is, I mean, there are actually these cost drivers are actually based on the various attributes of software development environment. Okay, so that is what. So there are certainly some drivers. Okay, so they will be multiplied. Okay, they will be multiplied. Okay, so these values will be multiplied. Okay, these cost drivers are multiplied with the initial cost and effort estimates obtained from basic COCOMO appropriately to scale to up or down. Okay, so now let's say, for example, so if you have used, let's say, if modern programming practices are used, then the cost driver value will be less than 1. is multiplied to downward the scale of initial estimate. Why it is the cost driver will be less than 1? If you are using any modern programming practice, why it will be less than 1? Can anyone?
It decreases our efforts.
Yes, that actually decreases. If you, because let's say if you multiply it by 1.5, what will happen? The effort will increase. Okay, but if you multiply it with less than 1, that means the effort will decrease. Now, why this effort will decrease? Because you see, let's say yesterday you were using you were using C programming language to develop the software. Now today you are going to use object-oriented programming language. Now you know that object-oriented programming languages are better in terms of what? In terms of reusability. So you will be able to reuse the code properly because of those inheritance and all that sort of the features that you have in object-oriented programming language, right? So as a result, what will happen? Some effort will be reduced. Okay, so that means you sometime these estimates will be scaled up or down by multiplying a cost factor, and this cost factor, so there are 15 cost factors considered by COCOMO, intermediate COCOMO model, and you will be multiplying them. Okay, so if stringent reliability requirements on the software, initial estimates are scaled up. So that means you can say, so if you want a very reliable software, that means what? You want a very reliable software. In that case, definitely, you need to think from every aspect, right? So the software should not crash any point of time. Okay, so it should be a much more reliable one. That means you need more effort, right? You need to give more effort, more time, right? So as to come up with a very reliable software, right? If that requirement is there, usually your effort will increase. Okay, I mean that will the factor which you multiply, so that should be a greater than 1. As a result, it will increase. So BOEM requires the managers to rate 15 different parameters for a project on a scale of 1 to 3. So now, as I told you, so there are those 15 cost drivers, right? So for all of those things, so the project manager will rate, let's say, reliability. Whether you want a high reliability, stringent reliability, in that case, what will happen? The value will be 3. If you want a very low reliability, so value will be 1. So likewise, for all these 15 cost drivers, so the project manager will rate a value between 1 and 3. Okay, with each grading suggested appropriate cost drivers to refine the initial estimate. Okay, after grading this, so the cost drivers will be multiplied so as to accordingly you will be going to get an appropriate cost. Okay, so now the cost drivers identified by BOEM, they can be classified, okay, being the attributes of the following items, maybe this way, right? One is the product, okay. So maybe they are exactly include some of these characteristics by default, right? So that means the reliability, okay, and how complex that particular product is. So these are the inherent ones that we'll be considering as part of product only. Okay, now maybe because computer execution is also important, right? Or the storage that you have provided, that is also important, right? If your computer, if you are using a better computer, okay, for developing that particular software, so in that case what will happen? So now the quickly you will be able to run your program, okay, whatever the program that you have developed. And storage also, if you have a large storage, that will be better in terms of, let's say you have a physical memory, okay, so which has maybe 8 GB RAM if you have, so you will be able to run your programs very faster because your data structure can be managed very nicely, okay, because you have enough space, right? So this way you can think. So if you are using a better computer, that will also reduce the effort, right? If you are let's say the person who is going to write the program, okay, so if he's a very experienced one, in that case what will happen? He will also write the program very quickly, efficiently. Okay. Now, if there is a less experienced person, so usually he will take more time to develop that code. Okay. So now these sort of things also be considered. Okay. So that will be coming under the category of personal. Okay. And the other category here is a development environment. That is what I told you. So you will be using some tools like IDE is one of the example, integrated development environment. If you're using that one, so like all of these cost factors, they are maybe based upon each one of these categories. They're going through each one of these categories. Okay, do you understand any doubts so far? Any doubts so far? No. So now the final slide here is a complete COCOMO. Yes. Susri, you ask me.
No, sir.
Okay.
No
So
doubt.
now the final one is a complete COCOMO. Okay. So basic intermediate model considers software product as a single homogeneous unit. Okay. So they consider this is a very homogeneous unit. Okay. But large systems are made up of several subsystems, right? So I mean, what according to basic and intermediate model is that so the whole system is considered as a homogeneous object or the entity, but this is not true. When you talk about a large system, so they made up of various several subsystems, right? And these subsystems will have their own different characteristics. Okay, so one subsystem will have certain different characteristics from the other subsystem, right? So now so you can think of like this. So one subsystem may be considered as a organic, the other one will be considered as a semi-detached, the other module or the subsystem may be considered as embedded, right? But but according to basic and intermediate, what you thought, we thought that either that whole software is a organic or whole software is a semi-detached or whole software is a embedded. So that is not true. Okay, so this is what according to complete COCOMO. So now, so the same sort of complexity we will be calculating for each and every subsystem. Okay, and yes, someone is asking. Okay, so something like this. Okay, so you have different complexity requirements. Okay, you have I mean in terms of complexity, so they might differ. Some of these subsystems, right? In terms of reliability, they might differ. So one subsystem require more reliable, has a more reliability requirement. The other one has a less reliability requirement. So this way. So for the one subsystem, the people deployed have a better experience. For other system, the people have little less experience, right? So now you need to take individually the subsystems and then you need to estimate the cost. This is what exactly part of complete COCOMO. Now this is the way that the whole estimation is carried out by Bohem. Okay, through these all three systems, through these three phases. Okay, so I think now I need to stop this lecture, right? So any doubts so far? Quickly. Students, do you have any doubt?
No, sir.
No, I think you understood everything, Kokomo. Okay. So I stop the recording. Just give me a minute.